just wanted to touch on some things with area and perimeter to kind of give you guys just a little bit of information and how to solve those. You've been working some of them on your own, but we're going to go over a few today and also talk about the area of a trapezoid and how that is a little bit different from the other ones that we've talked about. Now, we are doing area of quadrilaterals, which means they have 4 sides, and also a triangle, which has 3 sides. And each of their areas are a little bit different, but somewhat the same, especially when we're looking at the quads. Okay, so the first thing that we're going to talk about is the rectangle. And when we answer surface area, we always want to make sure that we do it in the correct units. So if it's inches, we answer in inches squared. If it's feet, we answer in feet squared. You get the point, centimeters, centimeters squared. So rectangle is super simple. You just multiply the base times the height. Now, you'll notice in some of your exercises that I've given you is I've asked you several questions about the difference between the areas of a parallelogram and a rectangle, and we'll get there. So, an example of finding the surface area for the rectangle is you're simply going to multiply whatever the base is times the height. So for instance, if it is 6 inches and the height is 4 inches, then the area, which your book designates R for rectangle, is going to be 6 inches by 4 inches, which is going to give you 24 inches squared. And that is the correct units, and that is how I want you to answer your problems. Okay, square is super, super simple. So we know, what do we know about a square? It's quadrilateral, all of its angles are the same, and all of its sides are the same. So a lot of times your book will just give you one measurement and say, what is the area of the square? Very simple. The formula for the area of the square is side squared. So you take what it gives you, which in this case is 10, you're going to square it. So your answer is 10 squared, which is 100 what? Centimeters squared. For the parallelogram, that is where I wanted to kind of talk about. That's what I wanted to kind of make sure that you guys were understanding today. You have a parallelogram. We know that they have 2 sets of parallel sides, so these are parallel and these are parallel, and these are our bases. Now, when you look at the area formula for parallelogram, you have to multiply the base times the height. But here is the thing, because the sides of a parallelogram are slanted, we do not use those as the altitude. So you'll notice in your book, it'll have something like this, maybe. And then it'll have the base is, I'm just gonna go with 9, okay? And so it might even trick you and put a side over here, but we don't look at that. We look at the altitude, which is going to be perpendicular from base to base. It will never be the slanted side. You cannot solve for surface area of a parallelogram by multiplying 9 times 6 like you can in a rectangle. The difference between a rectangle and a parallelogram is the rectangle's sides are perpendicular. They form 90-degree angles. So there's no need to draw an altitude line because that is the altitude. In a parallelogram, our sides are not 90 degrees, so you will always solve your area by multiplying whatever base you have. You may have this one, you may have the bottom one, by the altitude, which will be a perpendicular line drawn from the top base to the bottom base. So, in this example, we would say PL for parallelogram is equal to 9. Let's give it some units. Go ahead and give it some units. We're going to do inches. 9 inches times 4 inches, and that is going to be 36 inches what? Squared. Okay. Now, triangle. Triangle has a very different formula, only because it has this little half, the half in front of it. Now, if you look in your book, you will notice that it will always give you a height similar to the parallelogram. okay? We can't use the side of a triangle for the height. Now, sometimes it'll give you a different base, but we're just gonna look at just a normal triangle right now. So if this is your triangle, it may say that this is 8 centimeters, and it may say that this is 4 centimeters. So 4 would be your base, and 8 would be your height. So you would simply plug in 1/2, your base is 4 centimeters, times your height is 8 centimeters. Now, you can go ahead and multiply the 1/2 times the 4 and get 2 and multiply it by 8 to get 16. Or you can just do 4 times 8 is 32 centimeters squared, then multiply it by the 1/2, which is still going to be 16 centimeters squared. So in this case, it does not matter if you do this first or you do this first. You're gonna get the same answer. I wanted to give you an example of one of the problems I assigned you where we weren't really solving for the area, but your book kind of reversed it a little bit on you and was asking you for the altitude. So on page 240 in exercise 5.4, your book gives you an example. I'm going to go ahead and read that actually, because it says the area of a triangle is 176.66 square feet. So we know the area, we're not solving for area. The base is 24.2 feet, and it's asking you to find the altitude. Now, the difference in that is we're not solving for area, we know the area, we are going to solve for the altitude. But we know two things, so we can solve for the missing thing by using algebraic properties. So I want to give you an example of that. Okay. For solving for the altitude, and you can use this for any formula, you just have to manipulate your formula a little bit to solve for whatever it's asking you. So we know that our formula is 1/2 base height for the triangle. Now, the difference is we know the area. So it's 176.66 square feet. I'm going to do this because that means square feet. Equals, go ahead and finish the rest of your formula. It tells us the base is 24.2 feet, but we do not know the height. We do not know the area. So, how do we solve for the height? Well, the same way we would solve for any other variable, any other algebraic variable that we do. The only difference is we're doing area and h is not an x. Okay, so I would go ahead and multiply my 1/2 by my 24.2 to kind of clear the 1/2. So I'm just going to write my formula again. And 24.2 times 1/2 is going to give me 12.1, but I still have my h over here. Now, what am I solving for? I'm solving for h. So the goal is to get h by itself. Right now, I have h being multiplied by 12.1 feet. How do I get rid of the 12.1 feet? Well, if h is being multiplied by 12.1 feet, I simply divide by 12.1 feet. I'm going to go ahead and put my signs here and kill the 12.1 on that side, but what I do to one side of the equation, I always have to do to the other side of the equation. And so, that is going to give me, so now you have 176.66 feet squared divided by 12.1 feet. Go ahead and then plug that into your calculator. Now watch this with your signs. On top you have feet squared, on bottom you have feet. You treat units the same way as you would treat a variable, okay? So your answer is not going to be feet squared because that is the unit we use for area. Your answer is just going to be feet. This is like saying that this foot cancels out one of those feet. So 176.66 feet divided by 12.1 feet, that's going to give me 14.6 feet is my what? My altitude. So that is how you would solve for an altitude in contrast of solving for area.